Hello students, good morning. We will continue this exercise 16.2 from the question number 43. See the first bit of question number 43. It is given that in this figure, this triangular section ABC is an equilateral triangle, whereas this trapezium DEFG is an isosceles trapezium, and sides are given like this. DE is given 6 centimeter. So if we have this length DE, then if we draw the two perpendicular, then we can see this BCED is gives a shape of rectangle with the two opposite sides. This one DE is 6, and that's why this BE is also 6 centimeters. So now we have this BC. This BC is 6 centimeters, so we have one of the side of the equilateral triangle as 6 centimeters. So that means all the sides are 6 centimeters. So we have the side length of the equilateral triangle, so we can calculate the area for that equilateral triangle. Now see, what about the isosceles trapezium? So here, as because this length is DE, DE is given 6, so this BC is 6. Now see this triangle. Okay, here in this triangle, this is a right angle triangle at the point C. That means at the point C the angle is 90 degree. This triangle ECF, if we use the Pythagoras theorem here, then this length of this CE plus CF, the square of the CE, the square of plus the square of CF gives this hypotenuse EF, correct? So this is by the Pythagoras theorem. So by the same sense, we can use here this EC, the length of this EC is equal to square root of square of this EF minus the square of this CF. Okay, that means this is the hypotenuse, the longer side. So the square of the hypotenuse minus the square of one side gives the square of the third side, and if you take the square root, we will get the exact length. So this is EC. See this line, EC is equal to square root of EF square, that is this one 5 square, minus this FC square or CF square, that is 3. So square root of 5 square minus 3 square, so this will give 25 minus 9 is equal to 16, and square root of 16 is equal to 4. So finally we will get 4 centimeter as this length EC. So this EC is same as this BD, which is the distance between the two parallel lines. So this is a trapezium, and the distance between the parallel lines, this EC is same as BC, which is 4 centimeter, which is considered as the height of the trapezium. Now for this triangle, see, for this triangle which is right angle at the point B, I am talking about this triangle DBG. So here, if we again use the Pythagoras theorem, we have this length, as this triangle is the trapezium is isosceles, so this GD is also 5 centimeter. See this GD, this DG is 5 centimeter, same as this length. Okay, so if we use the Pythagoras theorem here, this 5 square minus this BD, that is 4 square, gives the square of this side. So if you take the square root, we will get the exact length. That means, see, this BG is equal to square of DG, this DG is square of DG minus square of BD taken inside a square root. So here square root of 5 square, that is 25, minus 16, 4 square 16, 4 square means 16, it gives square root of 9, which is equal to 3. So now this GB is 3 centimeter, as this CF is 3 centimeter, correct? Now we can calculate this total length. Now here this total length, you can see for this trapezium, isosceles trapezium, we have the height 4 centimeter, and we have length of one side DE is equal to 6 centimeter. See here, it is DE is equal to 6 centimeter, it is given, and one more side is there, one more parallel side is there, and we have, in order to calculate the area, we need the length of the two parallel sides. So this one is the another parallel side GF. So see how the length of G is calculated. See the second last line, it is equal to, see the second last line, it is GB is equal to GF is equal to GB plus BC plus CF. So this length plus this length plus this length, and this one is 3 centimeter, as we have calculated this. C. So here this GF become 12 centimeter, 3 plus 6 plus 3, correct? Now see this page, here we are in the same question again. So we are calculating the area actually here. See this, for this equilateral triangle 6 centimeter is the side, and for this isosceles trapezium, we have the height 4 centimeter, we have one of the length 6 centimeter of the, we have the length of parallel side, one is 6 centimeter and another is 12 centimeter. This one is 12 centimeter. See, 3 plus 6 plus 3. Now we have to calculate area enclosed by this figure. So first the area of triangle ABC, and then area of trapezium EFG. So the area of an equilateral triangle is equal to root 3 by 4 side square. So side is given 6 square, side is given 6 centimeters, so we will take 6 square, and this is added with the 1 by 2, 6 plus 12. This is the sum of the parallel side. 6 means one parallel side, this one, and 12 means this another parallel side. So we know that the area of the trapezium is 1 by 2 into sum of the parallel side into height. So these are the two parallel side into 4 is the height. Okay, so if we calculate those, we'll get, see, square root 9 root 3 plus 36, and 9 root 3 is equal to, root 3 can be taken as 1.732. So if we take 1.732 in the place of root 3 and multiply with 9, we'll get 15.6, near about 15.6. So we have the value 15.6 plus 36, which is 51.6 centimeters square. So this is the required area enclosed by this figure. Now see the next bit. Here we have, yeah, bit C. See, I'm solving here bit C, and you just see this one, and you'll get the idea how to solve the bit B for this question, for the same question 43. Here, this is the figure that we have. In this figure, all the measurements are, all the sides are given. See, so firstly, total area of the cardboard. This is actually cut from a cardboard, and the area of the cardboard is 24 into 24 centimeter. It is given 24 centimeter into 24 centimeter. So we have this one 24 centimeter into 24 centimeter, which is equal to 576 centimeters square. So this is the area of the cardboard. Suppose this one is the cardboard. Okay, this one is the cardboard, and from that cardboard, this white section you can consider. This white section is a cardboard. 24. See the length here. This length is given 24, and this length is given 24. See the last, it is an arrow is drawn here at the last, at the bottom. So this shows that this one is a section of cardboard. That means this M shape is cut out from a 24 by 24 cardboard. Correct. So in this 24 by 24 cardboard, the total area, if we want to calculate, so it is 24 centimeter into 24 centimeter, which is equal to 576 centimeters square. Now we have to calculate the area of this section, this figure. So here in this figure you can see, yeah, by the different color you can easily understand this one is a rectangle and this one is a rectangle, and this one is a parallelogram and this one is a parallelogram, and we know how to calculate the area of rectangle and how to calculate the area of parallelogram. So first, see, we need the parameters. So let's see first. Here 24 is this length, okay, and this one is given 6 centimeters. So 24 into 6 gives the area of this rectangle, and this is same for this rectangle. So we can easily calculate the area of that rectangle. Now see, what about this parallelogram? So here, as this length is given 16 centimeter, so that means from this point to this point the length will be 24 minus 16, because this part is 16 and total is 24. So 24 minus 16 gives 8 centimeter. So this length we get 8 centimeter. Now as we are seeing that this line and this line are parallel, and it is actually a parallelogram, so opposite sides are equal in a parallelogram. So if this length is 8 centimeter, this length is also 8 centimeter, and this length is also 8 centimeter. Correct. So for the parallelogram we can consider this one as a base. Okay, so for that parallelogram, this one is a base. So this base is 8 centimeter for both the parallelogram, because both the parallelogram are identical with their shapes. Correct. And the lengths also. So here we have 8 centimeter for it is the base of the parallelogram. So what about the height? So let's see here. It is given the total length. See, the total length is 24. Okay, and this section is 6 centimeter and this section is 6 centimeter. So what left? 24 minus 6 minus 6, that is 12 centimeter is this arrow. This arrow gives the length 12 centimeter. Okay, this arrow gives the length 12 centimeter. Correct. So if this is 12 centimeter and those two parallelograms are identical, so that means this should be the midpoint. Okay, their height, their total height, that means the height of this parallelogram is equal to height of this parallelogram, and the sum of their height will be 12 centimeter. And as those two are identical, so we can directly take that this section is half of 12 and this section is half of 12, and total from this point to this point is given, from this point to this point is given 12 centimeter. Okay, so out of this 12 centimeter we will say that the height of this parallelogram is 6 centimeter and the height of this parallelogram is again 6 centimeter. Those two parallelograms are identical. So now for those two parallelograms we have the height as well as we have the base. The height is 6 centimeter and the base is 8 centimeter. So we can calculate their areas. So let's see here the area of the cut off section. This is the cut off section. Okay, now this M section is cut off from the cardboard. So the area of the cardboard section, the cut off section, see 2 into area of rectangle. See it is colored with green. Okay, so this means that rectangle. So 2 into 2 rectangles are there, so that's why 2 into area of rectangle, and 2 parallelograms are also there, so 2 into area of parallelogram. See the colors also. Okay, I'm calculating the area of this section, these two sections. Okay, so the length of rectangle, the area of rectangle, you know, length into breadth, and the area of parallelogram is equal to base into height. So we have the length and breadth as we can take here 24 into 6, and this one is base is 8 centimeter into 6 is the height. So if we multiply those, we'll get 288 into sorry plus 96, and this will give the total area 384 centimeter square. So this is the area of the cutoff section, that means area of this figure. Okay, and it is the sum of the this angle, this rectangle, and this parallelogram and this parallelogram. So finally, if we want to get the remaining section, the area of the remaining section, see area of the leftover section, then we will subtract the total area. See, we will subtract this area from the total area. So 576 minus this 384 gives 192 centimeter square. So this is the area, this is the area of the section which left over after cutting out this portion from the cardboard of 24 by 24. Correct. So this is the answer. 192 is the answer. See, 192 centimeter square. This is the required area. So now I am leaving the first bit of this question number 44, and I am only solving the bit B. Okay, here you have three bits, bit A, bit B, and bit C for the question number 44. And here I am solving only the bit B. See the solution, try to understand. If you understand this, you can easily solve the first bit as well as the last bit. So see first, here in this given figure we have many, see the triangles we have, and one trapezium also we have. So suppose the lengths are also given. So suppose we consider this AED as a whole triangle. I know that here two triangles are assembled, this AEY and EYD, but I am considering the whole triangle AED because we have this height, this one is the height 20 centimeter. Here this length is actually the height, it is meter, it is in meter. So this is the height for this triangle AED. And if we want to get the base, so see this total length AD is the sum of this individual length 12 plus 15 plus 10. So this is done here. AD equal to base AD equal to 12 plus 15 plus 10. So we have 37 meter as the base, and we can take this one as height. So area of the field is the area of AD plus the area of AXB. So for this AXB, see this, for AXB you have this one as height and this one as base. So you can use the formula half into base into height. Correct. Now for this trapezium, see for this trapezium you have 15 you have this one 30, this side is 30 centimeter and this is 25. So you have the parallel sides, you have the length of parallel side, these two sides are parallel, and this 15 centimeter is the height, 15 meter is the height. So if we have, for a trapezium, if we have the length of the parallel side and the height, then we can easily calculate the area enclosed by this trapezium. And one more, this one is the triangle. Okay, if this is a triangle, this is the height and this is the base, we can easily calculate the area. Now we can calculate, as we can calculate all the areas. So see, individually the areas are calculated. Here the area of the field, area of AD, that is this bigger triangle AED. Then after area of AXB, this one is AXB. Then after area of BCZX, that is the trapezium. So BCZX is the trapezium, and then after area of this CZD. Okay, so here it is area AR. Okay, now AR means area. So see, we are using the formulas for this AED. It is 1 by 2 into 37, which is the base, into height, which is 20. Correct. And now for this AXB we have half into 30 into 12. See, half into 30 into 12, half into base into height. Now the trapezium, we have half into the sum of the 30 plus 25, that is 55 into 15, correct? See, half into 30 plus 25 into 15, sum of parallel side into height. Now the last one, this CZD. So for this CZD, we have half into 25 into 10, correct? Half into 25 into 10. Now we can calculate those values. This one is 740, this one is 360, this one is 360, this one is 55 into 75, that is 825, and this one is 225 into 10, that is 250, and half is taken common. See, we have, see the last line, we have half into 2175, and if it is calculated we will get 1087.5 meter square. So this is the required area of this field. This is the area calculated for this field. Okay, and for the calculation we have used the individual parts and then after added those areas, added the areas of those individual parts, correct? So this is how we can calculate the others. See here, bit a is also given. If you see the bit a, here you have two trapezium. Okay, you can consider one trapezium. You just make a line, you just draw a line, that is 1.2 meter is given. See the book, okay na, 1.2 meter is given, a line given 1.2 meter. So that line you just extend toward the line of 1.8 meter and join. Okay, so there, then after you will get one section as a trapezium, okay, with two sides parallel, the upper one and the bottom one, and then after one section become the rectangle, correct? So you have to just add the rectangle with the 2.4 meter and 0.3 meter. Just draw the line, okay, just draw the line from one point, I'm telling from 1.2 meter, you just extend the line toward the base and join. Okay, and in your left you will get a rectangle, and in your right you will get a trapezium, correct? So do this, and the bit C, you just think you can solve. Okay, all the things are given. Now I'm going to the next question, that is question number 45. So here in the question it is given that if the length and breadth of a room are increased by 1 meter. So here you can see, firstly we are considering the length, initially the length and breadth of the rectangle be x meter and y meter, correct? So see this figure, this is the length x meter and this is the breadth y meter. So we have the area x into y. Okay, and suppose if we are increasing the length and breadth by 1 unit, that is 1 meter given, so it is x plus 1, y plus 1 meter and x plus 1 meter, correct? Length and breadth both are increased by 1 meter, correct? So for that we have the area x plus 1 into y plus 1, correct? And it is given in the question, if it is, if this breadth and length is increased, then their area is increased by, the area is increased by 21 meter square. Okay, so from the question, according to the question, we can write initially the area is that much, so finally the area is increased, so we will write the final area, that is x plus 1 into y plus 1. This is the area of this one, and it is subtracted to the initial first area, okay, that is x into y. So calculate this. See, only the multiplication is done here, and we will get x plus y. See the last line, x plus y equal to 20. So this one is taken, transported toward this side, so that's why this is 21 minus 1, 20, correct? And x and y will left here, because this this xy and this minus xy will cancelled, correct? So one equation we have, x plus y equal to 20. Now see the next page. Here we have the question again. In the question it is given that when the length is increased by 1 centimeter, okay, but the breadth is decreased by 1 centimeter, 1 meter actually, length is increased by 1 meter and breadth is decreased by 1 meter. See from the figure you can easily understand, this one is the initial rectangle and this one is the final when changes is made. Okay, so the length is increased and the breadth is decreased by 1 meter, correct? So now we have, this one is the area, it is given in the question the area is decreased, area is decreased by 5 meter square. So we have this one, the area x into y, so x into y is the area, and the after changing the area, we have x plus y into y minus x plus 1 into y minus 1, correct. So x plus 1 into y minus 1, this is the new area. So this is the area which is greater, and then after this is the new area which is decreased by 5. So when we subtract this area with this, we'll get 5, correct. So this is the greater area, this is the smaller area, the subtraction, after subtracting we'll get 5. It is given in the question that the area is decreased by 5 meter square, correct. So now the calculation is same, xy cancelled, x minus y is left, this one is taken, transported toward this side, and we'll get 4. So x minus y is equal to 4. Now from this relation we can take x equal to 4 plus y, correct. This y is taken toward this, so we have x in terms of y, so we can substitute this value in that equation 1. So we will put this value in equation 1 for that x. So x plus y is given 20. Now see the equation 1, x plus y is equal to 20. So here in the place of x we can write 4 plus y is equal to 20. This bracketed section is actually the x, we are replacing the x. So this y plus y, and this 4 is taken toward this, so 20 minus 4 is 16. So y is equal to 8 meter, correct. So if y is equal to 8 meter, then see x is equal to 4 plus y, that means 4 plus 8, that is 12 meter. So we have the length x 12 meter and the breadth y as 8 meter, correct. Now it is given that we have to find out the perimeter. So we have the length and breadth, and we have the formula for the perimeter, 2 into 12. See the second last line, 2 into 12 plus 8, so 2 into 20 gives 40. So 40 meter is the perimeter of that rectangular room. Now see the next. In the question number 46, I am giving only the hint. It is given that in the figure, a triangle and a parallelogram have the same base. Okay, so suppose the base of the triangle is 28, it is given. So if the base of the triangle, and for the triangle we have the 3 sides, we have the length of 3 sides, so we can use, in order to find out the area of the triangle, we can use the Heron formula, because 3 sides are given. And for the parallelogram, it is given that the base of the parallelogram is on the side 28 meter, 28 centimeter side of the triangle. So that means the base of the parallelogram is same as 28 centimeter. So if the base is 28 centimeter, we can consider the height h, and it is given that in the question that those two has equal areas. So area of the triangle, first we will find out area of the, and the area of the triangle, and then equate it with the area of parallelogram. As here we are taking the h is as the height, h is considered as the height of the parallelogram, then we can calculate the value of, we can solve for the value of h. We will get, after putting those value, we will get this h. So solve this. Now this is question number 47, the last question that I have solved here. In the question it is given that in a rectangle of area 105 centimeter square has its length x. So x centimeter is taken as the length, and as the area is given, and we know the formula for area is x, that is length into breadth. Okay, so length is given x, so x into breadth is equal to 105, that is the area 105 centimeter square. So breadth is equal to 105 divided by x centimeter. So now we have the breadth in terms of x, correct. So this is one of the answer. Now it is given that the perimeter is equal to 44 centimeter, and we know the formula for perimeter, 2 into length plus breadth, and we have this length as x. See, this length is x and this breadth is 105 divided by x. So we can put those values, 2 into x is length plus this is the breadth, 105 divided by x, it is equal to 44 centimeter, which is given as the perimeter, correct. So here if we solve, this 2 is taken toward this side, so 1 by 2, 2 become 1 by 2 on this side, so 1 by 2 into 44 become 22, and here this is x is taken as x square plus 105, and when this x is multiplied to the right hand side, we will get 22x. So x square plus 105 is equal to 22x. When 22x is taken toward the left hand side, we have x square minus 22x plus 105 is equal to 0. Then this 22x can be broken like that. You have read those things in factorization, so remember that one. So 22 is broken like that, 15x plus 7x. So as it is minus 22, so we can write minus 15x minus 7x. So this sum will give 22 and the product will give 105. because 15 into 7 is 105. So you can write x plus 15. See the second last line, x plus 15 into x minus 15, actually x minus 15 into x minus 7 is equal to 0. So by considering these two, we can write x is equal to either 15 or 7. So if we take x is equal to 15, then the length will be 15 and the breadth will be 105 divided by length. See the last line, okay, breadth will be 105 divided by length, that is 15. So 105 divided by 15 gives 7. So 15 centimeter and 7 centimeter are the length and the breadth of the rectangle. Now see the question number 48. Here we have the perimeter and we are considering the perimeter first, and it is given 108, 118, and we can for the breadth, see it is calculated 2 into x plus breadth is equal to 108, and this 2 is divided on this RHS part, and x plus breadth is equal to 90, and this x plus breadth equal to 90, so breadth equal to 90 minus x. So this is the breadth in terms of x, and then after we know that area is equal to length into breadth, and we have the length as x and breadth is 90 minus x. Then we can solve, we will get equation, then we will get an equation, then after we can solve for this x, and then after we will put the value for the breadth also. If we have the value x, then just subtract from 90, we will get the breadth also. So length and breadth will get easily, and this is my instruction that you just also solve this question, this particular question 48 number, as you have solved the question number 47. So try this, okay. That means you can use the area, and like the question that you have solved here, okay, first you can use the area and find the breadth in terms of x. So this is my instruction, and this is the book's instruction. So you just go through the book and then after verify your answer with this, okay, with this this method, correct. So thank you students, this completes.